Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have Scott Anderson. He's the CCO, the Chief Clinical Officer of SyncThink. SyncThink. We're going to talk about eye tracking and what it can do. So, Scott, thanks for coming. How are you doing?
Thanks for having me, Richard. I appreciate it.
Yeah, if you would tell me a little bit about your background and then about your current work at SyncThink.
Sure, yeah. So I come from the clinical world, trained expert in sports medicine and injury prevention care. I most recently, prior to joining the team at SyncThink, was in charge of the sports medicine program at Stanford University, where we provided a large multidisciplinary healthcare service organization to a large at-risk athletic population. So I was in charge of the staff there and also had my own clinical responsibilities there too as well. You can imagine being on a campus like Stanford, there's a lot of activity. And there's certainly a lot of multidisciplinary research happening on the campus, and I was involved in a number of activities, one of which led me to the founder of SyncThink, which is Dr. Jam Gajar, who is a neurosurgeon at Stanford, part of the clinical faculty there, and the founder of SyncThink. And we spent some time working together, several years, to develop or to commercialize the technology or to validate the technology to bring it to commercialized state. And when essentially the technology rolled out of Stanford, I joined the company to help its commercialization efforts.
Okay, and what's the premise of SyncThink?
Yeah, so SyncThink is a very novel technology that utilizes high fidelity research grade eye tracking infrared cameras and emitters that are built into a VR goggle, virtual reality goggle, and uses a series of 60-second assessments to capture your eye movements and to correlate them with various neurological conditions. This is something that Dr. Gajar has studied in partnership with the Department of Defense for probably the last 15 years or so. And we've been able to categorize various conditions based on the eye movement biomarker signal that we capture from our system. And so we can very rapidly quantify and identify any type of visually impaired signatures that come from a lot of these neurological conditions. And I don't know if you follow neurological health or brain health in general, but that's part of what's missing with many of these conditions, whether it be conditions that are related to development and attention disorders that are related to childhood development that get labeled as learning disabilities, or later in life when we have neurodegeneration and develop certain cognitive impairments. What they all have in common is that they lack objective information. And so it becomes a diagnosis of exclusion. And in many cases, the patient is diagnosed based on their reported experiences or their symptoms that they may have, which clues the doctor in on what to do for them.
What do you mean? Like, what's an example of a condition and what happens with someone's eye tracking?
Sure. So, typically, say, for example, dementia, for example, right? This is neurodegeneration. The brain is deteriorating, and there are a whole host of symptoms that come with. It's typically reported by the family when somebody is either pre-dementia or demented, any type of dementia that they may have, and there is no specific type of test to get that can allow the doctor to make an accurate diagnosis, right? They're just listening to the patient. They're having them, they're filling out some kind of standardized questionnaires, and they're making the diagnosis based on the information that's collected at that time. There is no way to functionally measure the brain to determine whether or not that's actually what's going on. And so we're using eye movements to classify these conditions and to provide more objective insight into the brain's performance through the eyes. So, and I'll explain a little bit more deeply after that, but that's just the premise of it, is essentially we can learn a lot about how the brain is functioning through the eye movements. If you're not familiar, the eyes are the only part of the brain that we can see, and the eye movements reflect how the brain is functioning. And so we have this very robust high fidelity system that we can capture these eye movements that you would otherwise not be able to see with the naked eye. And these whatever signatures that they may leave give us an indication about the type of impairment we may find. And so Dr. Gajar spent the last 15 years categorizing these different eye movements and associating them with different types of neurological impairments that are commonly found but don't use objective information in their diagnosis. So that's essentially what we're doing.
What's an example of an eye movement? I've heard from I've heard of a nystagmus, where I guess the eye jumps when it tries to look, let's say, left and right or up and down. But what do you guys see?
Yeah, that's exactly right. So we look for different types of nystagmus, and we look for different types of, for lack of a better term, jerking in a certain direction. So what we do is we provide a series of assessments that the patient has to perform, and that tells us how well they're oriented. And so they may perform abnormally during the task, which we should expect to see some type of output. And if they can't complete that output, or they complete it abnormally, we look for this type of signature potentially. So, for example, one of our most common tests is a pursuit task. So there is a target on the screen that goes around in a circle very slowly. People who are impaired, a certain population, people who are impaired, they can't keep their eye on the target as it's moving. What happens is their eyes jerk beyond the target's trajectory, and they stop and wait for the target to catch up to them, and then they follow it again. They jump forward. It's this recurrent, what we call an anticipatory saccade like movement that gives us an indication that someone is functioning abnormally. There are a whole host of other types of ways that we categorize these eye movement signatures too as well. It just depends on what we're talking about and what we're looking at.
Do the people that you work with, do they know that they have a problem, or are they surprised by what the test results show?
They know something is wrong. In many cases, people in their lives have made accommodations for things that they are not aware of themselves that are part of what make them who they are, right? And so if you can show them that there's some objective reason why they are the way that they are, or the way that they have gone through life, adapting, it's really eye-opening. So, for example, we can pick up, visual suppression. So this is like the brain has neglect for a certain side of the visual field. So, maybe the left side of the left eye, the complete left side of the left eye is completely, the brain doesn't know that there's anything there. And so if you're driving a car, it's very difficult to do safely. And so this can be corrected with therapy and treatment. And in many cases, people don't know that the brain doesn't recognize that there's something off in their periphery of their left side, and they don't interact with it. And so when the patient comes to you, they sit down and they place their keys and their wallet and their body shifted all to the right side, because they're, as far as they know, there's nothing on the left side. So there's little things like that we help them identify, that depending on their age and their condition, we can correct, and we can certainly, uncover more information about what's going on, and help guide the physician to make decisions about the proper diagnosis and treatment plan.
Yeah, that's interesting. So eye tracking, I don't know, is it regulated by FDA? Is it part of any standard of care? Like, what's the path for it?
Yeah, so we are FDA cleared medical device, and I would say eye tracking has been very commonly utilized in neurocognitive research in, over the past 30 years. It really hasn't made its way into, clinical care of patients up until probably the last decade or less. And so we're kind of pioneering that effort to bring these unique measurements and this technology to clinicians and providers who can implement them as part of their clinical workflow and to help them make more informed decisions about the patient's disposition.
I don't know, what are the most prevalent conditions that this is used for? And, if I speak to, what kind of doctor would know about it? How do people even get this analysis done?
Yeah, so I would say, we see changes in brain function over the course of a lifespan. And so in kids, they have a developing brain. And so in many cases, kids are labeled, if they have problems with comprehension or reading in school, they may be labeled as having a learning disability or having an attention deficit disorder. And so in many cases, our system can be utilized to identify whether or not that's actually a legitimate diagnosis. But more importantly, it can guide whoever is performing the task, whether it's the pediatrician or some type of specialist, to learn more about the type of intervention that's necessary to correct it. In many cases, these kids, 30% of kids have this type of problem, and in many cases, they don't improve with medication. And so, that's been our MO in this country, is to medicate, and try to, correct the problem that way. But in a large percentage of the population in kids with developing brains, it doesn't do anything for them. So, we're essentially positioning our technology as an alternative in the developing brain situation. In adults, we see, in particular, concussion being a very large prevalence of visual impairments and eye tracking difficulties that come. Visual and vestibular dysfunction are very common after concussion. And so many of the neurology people who treat concussion, any specialist or physical therapist or even sports medicine trained personnel will use this technology to aid in the diagnosis and to track the recovery of these patients after concussion, both in sports and in lay people. And then later in life, as we talked about with, an aging brain, being able to identify whether or not, these changes in their eye movements correspond to certain diseases.
But what will happen after someone has a concussion? What will typically be seen? Yeah,
so what we see is, in many cases, what's disrupted, because concussion is a functional injury. It's not damage to the anatomical structure of the brain. And so what we see is the wiring of the brain is disrupted, which leads to problems with visual processing. So the brain has to utilize the eyes to select visual information and to process it so that we can react with our bodies or with our mouths. And in many cases, that process is disrupted in patients with concussion. And so our technology can identify that and can alert the clinician as to the severity of the problem and can guide them through our series of assessments specifically to what areas are dysfunctional and what is the appropriate remediation strategy to get it to resolve. And so that's essentially how we work with many clinical folks, both in sports, in the military, and in healthcare who treat concussion. Is that's essentially how they use the technology.
Can you tell, you do longitudinal work where someone will come in, do the test, come back a month later or a year later, or do them over a series of years. Like longitudinally, what do you see? Can you see decline in certain people or, progression or improvement, let's say with concussion?
Yeah, certainly with concussion, we see quite a bit, and even in my own experience, we see quite a bit of people who have had a history of concussion who have not had any proper rehabilitation. I think what the issue we're faced with in our country is that we have, millions of people who are suffering from concussion, but really the standard of care today is, pediatricians and primary care doctors are choosing to isolate these patients and have them sit in a dark room until their symptoms abate and they can resume their normal lives. But what's happening in many cases is that these individuals are suffering and having dysfunctions that can be measured, that our technology can identify, that is the source of their symptoms. And so in many cases, we see people who still have lingering problems that they've just learned to deal with, and they've never been evaluated or, more thoroughly assessed to identify the types of dysfunction they have. And they show up, 2 years later and they still have the problem. And so this, necessitates obviously the rehab that should have been done the day after the injury in order to correct the problem. Conversely, we see the same thing. We can track the recovery in many cases. These patients that are seeing concussion specialists are doing so on a weekly basis. And so this can be tracked. The recovery can be tracked. And I'll tell you, it's really eye-opening and really motivating for patients to see their own progress. And so if you are selecting a specific type of rehabilitation and a week later the patient's improved, their motivation skyrockets, and you really see the benefit of proving to them that your treatment that you've selected for them is working and effective. And that typically shortens the window of time that it takes for the patient to feel better and to fully correct the problem.
Well, what kind of treatments are there or exercises? I didn't even know that there were some. That's good there are.
Yeah, you've just proven my point, is that people don't know that, and people don't realize that you can actively rehabilitate a concussion, and you shouldn't settle for anything less. So it depends on the scenario, right? You can have anything from persistent headaches to neck pain to vestibular dysfunction, which throws off your balance centers and your ability to orient to things in the world around you while you're in motion, like while you're moving around. It's how you receive sensory input. It's something that's extremely common. And then we have the visual dysfunctions, visually processing information, seeing double, not being able to fixate or concentrate on specific areas in your visual field. Those are all things that are extremely common that occur in concussion, but all have a different rehabilitation pathway. And so the key is to be able to isolate those key impairments and to specifically create a treatment protocol for them. And so you may do a completely different type of treatment and rehab for somebody with neck problems because they were in a motor vehicle accident versus somebody who's having a visual problem because they were a football player and got tackled and landed on the back of their head. And that's where we have to go with improving the quality of care and the standard of care of concussion is really getting people to buy into active rehabilitation, and for patients really to advocate for that, because in many cases, the people who they're seeing either in the emergency room or, the primary care doctor is not, the proper specialist who's trained in concussion to treat the problem.
I guess the good thing is that not only can you diagnose, hopefully with some nuance, what's going on with someone, but you can, give them treatment, and then you can specifically see, it's not working. You got to try something else, or it's working really well. Let's continue. So your system allows all of this to happen, which is great.
That's right. Correct.
So what, I don't know, are there any conditions that are still tricky, that are not amenable to this, or the conditions are just, the person's going to decline no matter what? Like, for instance, Alzheimer's. Is there anything you've noticed with your system that regular science doesn't know?
Yeah, certainly. I think with the host of the neurodegenerative disorders, Alzheimer's, Parkinson's, schizophrenia, those types of conditions where, there are distinct eye tracking abnormalities associated with them. In many cases, we are not able to, our system doesn't correct the problem. It's, in many cases, we're identifying people too late, right? And so in situations like dementia or early onset, can we slow the progression by instituting some type of therapy? That's, I think, an interest of ours. I would say beyond that, it's, working with pharmaceutical companies to better understand how drugs can positively impact quality of life for these patients, because as of right now, that's the sole treatment for these types of what we would consider to be chronic conditions.
But are there any, do you see the degeneration with your tests, or are there flickers you see or changes, or, what's some of the nuance of what you learned with your testing? Yeah,
so they each have unique eye movement signatures, and they each have what we refer to as predictive errors, which means, they can't properly anticipate incoming information. And so, that's what the focus of many drugs are trying to deal with, is to slow the errors that are associated with visual processing of information or motor dysfunction. In the case of Parkinson's, we are learning a lot about that still, and still trying to figure out essentially what is the best protocol for assessing these patients and monitoring them over time. Because if they're not on the right drug or they haven't changed drugs often, their results are going to be kind of all over the place, right? So how do we work with these companies to find the best mix, I guess. So it's still an open-ended question, and something that we're very interested in. And we have, I want to say, 4 ongoing studies right now in those different areas to investigate that further.
What's the future of the eye tracking? Where are you going to take it? What's new, and what's coming?
Yeah, so the part that we're really excited about is that eye tracking is essentially going to be standard in all future AR head-mounted displays. So if you're familiar with augmented reality, you know that most of the ones that are coming to the enterprise market are going to have standardized eye tracking features. And so this will be, we believe that this will be a huge boost to not only to people like us who are very interested in eye tracking and provide a lot of the solutions in the software and analytics side, but also to have, various hardware partners like we have with Magic Leap, where we can leverage their hardware technology and their built-in eye tracking components for healthcare purposes. So that's the future, is really being able to leverage that technology as it relates to the work that we do.
Well, very cool, Scott. Where's the best way for people to find out more about SyncThink?
Yeah, you can go to our website, syncthink.com, synctink.com. And you can follow us on our social media pages on Instagram, Facebook, Twitter, and LinkedIn.
Well, very good. Scott, thanks for coming. I appreciate it.
Thank you very much. I appreciate the time.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.